In this lesson, we're continuing our rules of exponents that involve multiplying monomials. In the previous lesson, we just simply learned how to multiply monomials by keeping the base and adding the exponent. Now we're going to take those a little bit further and talk about two more rules. The first rule is the power of a power. Power meaning a whole thing of exponents. The rule is going to be a to the m to the n. This is my power right here, and I am taking it to another power. So power of a power. When we have that, a power of a power, we're going to be taking a to the m times n. So rather than adding, we're going to be multiplying our exponents. If you think about it, let's say I have 2 to the second to the third. That's like saying 2 to the second times 2 to the second times 2 to the second. Well, now we're adding our exponents. So 2 plus 2 plus 2 is 2 to the sixth. But in reality, 2 times 3 is 6 too. So this is just a shortcut for power of a power. The other rule that we have to learn is power of a product. That's saying if I have A times B, so some monomial, maybe two variables, a number and a variable, and we're taking that to another power. So I've got my power of a product. Here's my product, I'm taking it to a power. When we do that, we are going to distribute the power of the m to each term. So in this case, a and b both have powers of 1, a to the first to the m times b to the first to the m. Well, simplified, this is a to the m, b to the m. And that's the rule for power of a product. Just remember, it's like the distributive property. You're taking that exponent to every single term inside the parentheses. Let's look at an example now. We have x to the fifth to the second power. Well, when our exponents are right next to each other like this, we're doing our first rule, power of a power, and we're going to multiply our exponents. 5 times 2, and we get x to the 10th power. Same thing with this example, 5 to the 6th to the 8th. I can write out 5 to the 6th times 5 to the 6th 8 times, or I can multiply the exponents together. Keep the base, multiply the exponents, and you get 48. So 5 to the 48th power. Now pause the video and try this last one on your own. Alright, looking at it, we have x, keep the base the same, multiply the exponents. X to the 3 times 4 is x to the 12th. Very good. Now let's look at examples of power of a product. We're going to take this exponent of 2 and distribute it to each term on the inside of the parentheses. So I'm going to have 4 to the second power times x cubed to the second power. When I simplify this, we have 4 squared, which is 16, x to the third to the second power. We're going to keep the base x, multiply the exponents, and we have 16x to the 6th. Looking at the next problem, we're going to take the same concept. We're going to distribute our power of 3 to each term. But I want to make sure that I put -2 inside the parentheses, because it's very important. If it's inside the parentheses, especially if you're using the calculator, you're going to get a negative answer since this power here is an odd number. But first of all, if it's an even number, it's going to become positive. And if you don't use parentheses on your calculator and it's an even exponent, it's going to give you a negative and it's going to give you the wrong answer. So always put parentheses, especially if you're unsure. So we have -2 to the third times x to the first, since there's no exponent, to the third. Well, negative 2 to the third, remember, it's not negative 2 times 3. It's negative 2 times negative 2 times negative 2. And this is going to be equal to negative 8x to the third power. Now I want you to try this last problem on your own. Pause the video, and then when you're ready, come back. All right, looking at this, we distribute our exponent of 3 to each term. So we have negative 3 to the third times x to the fifth to the third. Well, negative 3 to the third, that's negative 3 times negative 3 times negative 3. It's going to give you negative 27. And x to the fifth to the third, we keep the base and multiply the exponent. So we're going to have negative 27x to the 15th. Now the problem is getting a little bit more complicated because we've got 3 terms inside the parentheses. But nothing's changing. Distribute the power of 3 to each part. So negative 3 to the third times a to the third times b to the fourth to the third. And then let's simplify. Negative 3 to the third is negative 27. A to the third is just a to the third. And b to the fourth to the third, we're going to keep the base of b and multiply the exponents. And so our final answer is negative 27, a to the third, b to the 12th. Now, this problem, we're going to still take that same logic, but then we're going to have to simplify further because we're multiplying 2 powers of a product now. So let's take it one step at a time. You're going to take the 3, distribute it to each term on the inside. So we have 2 to the third times m squared to the third times n cubed to the third. Well, let's continue with this for a minute, and we're going to see that 2 to the third is positive 8, m squared to the third is m to the 6th, and n to the third is n to the 9th. All right, moving on to the other side, this is all times, we're going to distribute our power of 4 to each term. So we have 3 to the fourth times m to the third to the fourth times n to the fourth. Well, we now need to simplify our answers, and we get 3 to the fourth, which is 81, times m to the third to the fourth, keep my base, multiply my exponents, so m to the 12th, and n to the fourth. Now, even though we've simplified each of those, we're not done. We need to simplify this entire multiplication expression. So we're going to put our numbers together, 8 times 81, our m's together, m to the 6th times m to the 12th, and our n's together, times n to the 9th times n to the 4th. Notice I haven't done any math. I just reordered my 2 terms. I put my numbers together from here, my m's together from here, and my n's together from here. Now we can simplify, and we see 81 times 8 is 648, m to the 6th times m to the 12th. Now, we're not doing power of a power, we're multiplying 2 powers. So we're going to keep the base, add the exponent. 6 plus 12 is 18. And same thing with the n's. We're multiplying, so we're going to keep the base, add the exponents. And our final answer is 648, m to the 18th, n to the 13th. All right, I want you to pause the video and try this problem on your own. All right, looking at this example, we're going to simplify by doing our exponents first. So I'm going to take this power of 2 and apply it to each term on the inside. So I have 2 squared, I have x squared, I have y squared. Sorry. Then I have the remainder, which is negative 3x squared times 4y to the fourth. Simplifying this, we see that we have 2 squared, which is 4, x squared, y squared, times negative 3x squared times 4y to the fourth. Well, putting all of our numbers together, our x's together, and our y's together, we see that we have 4 times negative 3 times 4 times x squared times y to the fourth. Simplifying this answer, we have 4 times negative 3, which is negative 12, negative 12 times 4, which is negative 48, x squared times x squared, keep the base, add the exponents, 2 plus 2 is 4, and then y squared times y to the fourth. Keep our base, add our exponents, 2 plus 4 is 6. Be very careful when you're solving these problems. Don't get these rules that you learned today, this power of a product of a power of a power rules mixed up with your multiplying monomials. I think the easiest way to remember is if the exponent is right next to another exponent, you multiply. But if they're separated, kind of like this, then you add. But that's just one way to memorize it. Either way, you need to know these by heart.